Hi, this is Lauren,
This is Annalise.
and we're going to be talking about plate tectonics today.
Plate tectonic theory began with Alfred Wegener's theory of continental drift, or the idea that continents move over time, and Marie Tharp's theory of seafloor spreading, which stated that oceans are spreading apart. J. Tuzo Wilson compiled these theories into plate tectonic theory, which says that faults are the boundaries of rigid plates, and that the Earth's entire crust consists of these rigid tectonic plates.
Plate tectonic theory relies on the fact that tectonic plates move over time and interact with each other. This motion is caused by convection in Earth's mantle, which is the molten layer below the crust. The upper part of the mantle is rigid, like the crust, while the lower part of the mantle is under high enough temperatures that the rock flows plastically. Plate movement is caused by convection cells in the mantle, where heated material rises toward the surface, cools, and sinks.
Divergent plate boundaries have high heat fluxes and are more common in oceanic crust. This is where a new oceanic crust is forming. The two oceanic plates are moving apart from each other, leading to this high heat flux and magma coming up, creating a new ocean floor. You're also going to see basalt rock in this area.
Continental divergent boundaries are less common than oceanic divergent boundaries. In some places, continental separation is the precursor to formation of a new oceanic basin. This is how the Red Sea formed. At these margins, rocks are pulled apart, forming a rift. Material from the mantle rises to the lithosphere beneath this boundary, just as it does in the ocean.
At convergent plate boundaries, plates move toward each other. Continental oceanic convergent boundaries is where the oceanic plate subducts underneath the continental plate because the oceanic plate is denser. Stratovolcanoes can form over this subducted slab, and we can also see oceanic trenches in these areas. There are examples of this on Earth, including the Ring of Fire, where stratovolcanoes are, and the Adian margin off the coast of South America, which has a subduction zone where trenches can form.
When two oceanic plates converge, one subducts under the other and melts due to the heat, just like oceanic continental convergence. Magma rises to form a curved string of volcanic islands. Trenches are formed, and earthquakes happen deep below the crust.
When two continental plates converge, the plates crumble and thicken, forming large mountain belts. Since these plates have the same density, they stay up at the surface. This crumbling and high pressure against each other leads to material rising up, creating mountain ranges like the Himalayas, the Alps, and the Appalachians. We can also see earthquakes here due to the high stress and pressure that the plates are under.
At transform plate boundaries, the plates move parallel to each other in opposite directions. As the plates scrape past each other, shallow earthquakes occur along the fault. These boundaries are on land, like at the San Andreas Fault in California, as well as in the ocean. Mid-ocean ridges consist of many segments of seafloor spreading offset by transform boundaries, rather than one continuous diverging rift.
In summary, plate tectonic theory explains many of the geological features and events that we observe, including earthquakes, volcanoes, trenches, and mid-ocean ridges. Measuring the motion of the tectonic plates allows us to learn more about the appearance and locations of past continents, as well as predict how the tectonic plates will move in the future.